All right, guys, so for the last part of the Chapter 5 notes, we're going to be going over 5.5, which is slope. Now, the objective for these notes is that by the end of this lesson, you will be able to define slope verbally. That means tell me what slope is, and compare slopes visually by looking at them in a graph. The essential question, how can you compare two graphs graphically? So that ties into the objective for today. How can you compare two graphs graphically? So just as a heads up, there are no 5.6 notes, which are direct variation. There is not going to be any of those notes. You're still going to see it on your test, but I'm going to remind you to skip a certain number of questions. So when you get there, we'll discuss it. So let's go ahead and begin just by reading the definition here provided for slope. So here, slope is the rate of change. That's very important right here. That's how we would describe slope, is the rate of change between any 2 points on a line. It is a measure of the steepness of a line. So let's put slope into terms that we might have a better understanding for. Let's say that we had a person here and a person over here. Let's make them two different colors. But we're going to love them the same, even though they're different colors. And let's say that this person is on a slide that looks like this. And let's say that this person got onto a slide that looks like this, and they're going on water slides. Now, which of the two has a greater degree of steepness? I want that to be written as a question. So which of the two is steeper? And it's very clear, at least I hope that it's very clear, that the green man has a steeper slide. That means that if they were both to jump at the same time, who would reach the ground faster? And we would say that the green person reaches the ground faster, because we could imagine ourselves going onto this slide, and this is going to fall way faster than this slide would fall. And so we would say that this is steeper, and the rate of change, that is the speed, is going to be greater. So that's what it's referring to, steepness. And we're going to tie that into today's lesson when we're discussing slope and the steepness of a line in a graph. Now, to find the slope of a line, to actually mathematically determine the slope of the line, you need to find the ratio of the change in y, that's the vertical change, to the change in x, the horizontal change, which is written as this formula here for slope, is the change in y and change in x. Now, I want you to write next to it that we can also determine this as the rise over the run. Rise over run. Now, what does that actually mean? So if we look over here, let me go ahead and erase this part. If we look over at the graph, it's telling us that the graph has a slope of 3 halves. So why does it have a slope of 3 halves? Well, the change in y, the rise, as you can see, is if you start at this point given, it goes up 3 spaces, 1, 2, 3. So we would put, for the change in y, we would put 3. And then the change in x, to get to the other point, the green point here, it goes over 2 spaces, 1, 2. So it has a horizontal change, or a change in x of 2. And so that's why I say that we can think about it as rise over run. It rises 3 units and runs over to the right 2 units. And so we would say that it has a slope of 3 over 2. So we're going to get into practice with that, of how to determine the slope by using the rise over run formula, which is change in y over change in x. Now, it's not always going to rise. Sometimes it's going to go down. For example, going back to our idea about the slides, these aren't rising, these are going down. But so when we get into downward slopes, we're going to not write it as a positive numbers, we're going to write it as negative numbers, but we're not just quite there yet. So just a study tip. The slope of a line is the same between any 2 points on a line, because lines have a constant rate of change. So if this line that's on the graph, let's say that this line described the speed of a car. As you can see, if this is describing the speed of a car, it's not changing at all. There's no changes in the graph, which means there's no changes in the speed. So that means that no matter at what point you decide to look at the car, it's always going to have the same rate of change, which means it's always going to have the same slope. So let's just make another note of that. Even though it's already given there, let's just make another note just so that I can see that A, you're watching this video, and 2, that we're going to keep that in mind, that straight lines have a constant rate of change which means the slope does not change. So if it has a constant rate of change, that means that the slope itself is not going to change. Alright, so moving out over here to the examples. Finding slopes. We're being asked to find the slope of each line, and we're given two graphs, graph A and graph B. And it's reminding us here that the slope of a line is determined by the change in y over change in x. So our rise over our run. Now we can see that if we start at point 0, 0 and we go to point 3, 4, that to get the rise, we would move it upward 1, 2, 3, 4 units. So we would say that the rise is equal to 4, while the run, or the horizontal change in x, is 1, 2, 3. And so we would say that the slope is 4 to 3, or 4/3. Or if you simplified it down, 1 and 1/3. So 4/3 and 1 and 1/3 both represent the slope of the line. It's the rise over the run. But we're not going to put it in mixed number form. We're going to keep it as 4 over 3. So for every time it rises 4, it's going to move over 3. Part B. We're going to start at -2, 2, and we're going to move over to 4, 1. And so maybe the question came up to you of why don't we start at 4, 1 and then move over to -2, -2. And the reason is because the graph is always read from left to right. If this is point -2, it's going to be, and let's say it was time, it would make sense that time would start at 0 and then go 1 second, 2 seconds, 3 seconds, 4 seconds. So graphs are always read from left to right. And here we start at -2, and to get to we start at -2 on the y-axis. To get to 1 on the y-axis, we would be going up 1, 2, 3, as they already labeled. So our change in y is 3. And then going to the right, we would be going 1, 2, 3, 4, 5, 6. So it has a slope of 3 to 6. Now, we can simplify down slope, and we still have the same rate of change. 3 to 6, we could simplify to 1 to 2. And you'll see here that if we instead now start at -2, -2, and instead of going up 3 and over 6, we use the simplified slope of going up 1 over 2, we're still going to get to the same point. We would go up 1 over 2, 1, 2. That puts us here. Up 1 over 2, 1, 2. And then up 1 over 2, 1, 2. And we still get to the same point. And we also always get to another point on the graph. When we went up 1 over 2 the first time, we ended up here still on the line. We went up 1 over another 2, we still ended up on the line. We went up 1 over another 2, and we're still on the line. So that slope is basically telling you how the line behaves and what point it's going to end up at. So if you had a starting point and you were given the slope, you can determine what the rest of the line looks like just by knowing that starting point. So on your own, you're going to find the slope of these two lines here. I'm going to let you do this one on your own because I feel like it is a very straightforward topic for right now. I don't want to assume that. So if you need help, make sure you're asking for help, or make sure you're looking back at the examples. But you're going to find the slope of these lines by determining the rise over the run. And remember that if it can be simplified, you're going to want to simplify that down as well.